So thanks for inviting me. I got the mail from Michel a bit late, or I didn't see the invitation mail in the beginning, but I thought this would be maybe very interesting. And also Oliver talked about different protocols before and REST. So we at Molecular Quantum Solutions kind of build a cloud platform, and we make use of application programming interfacing technology a lot. So came up with this title. Maybe one should not use CAPE-OPEN in relation to REST API, but this is kind of a white paper draft proposal. So what I will talk about is quickly just what we do at MQS, then also introduce what a REST API is for people who don't know the details about it. Then also what we work a lot with is this kind of container orchestration system called Kubernetes, which has become kind of the standard for kind of cloud infrastructure. And then some ideas how we would like to make use of COBIA, or at least look at COBIA to also shape out our framework or our REST API logic. And then I have also some references to parallelization with this kind of container technology and Kubernetes cloud infrastructure. So we as a company have some objectives. We want to perform multi-scale simulation, and we want to also combine quantum chemistry calculations in this kind of multi-scale framework. So this is something which has not been adopted very much by recent or the standard process simulators we have on the market. So we usually use kind of group contribution models, or somehow input the data we get from quantum chemistry modeling. Cosmo-IS, for example, kind of a breakthrough paper just came out some days ago where they managed to really obtain very nice results for VLE equilibria data together with Cosmo-IS and NRTL. So they basically calculate all the NRTL parameters and then feed it to you can store this into a process simulator. But we want to kind of build a platform which is more integrated with each other. And then of course we want to also have a kind of machine learning pipeline incorporated in this platform. Also, what is very important is this kind of notion of making use of distributed resources in the cloud. So some parts in your algorithm or some parts in your whole calculation scheme rather should be solved on a GPU than a CPU. Maybe you have some really good ideas of making even the algorithm even more high performant on an FPGA. And then also at MQS, we very much also look into patenting some algorithms on quantum computer infrastructure. So we have submitted 2 patents applications which reduce the number of qubits for quantum chemistry formulations to solve those kind of problems with the VQE algorithm on a quantum computer. And then also, besides test-driven development, we kind of have an API-driven software development practice where we really think about how users will access the software in the cloud and how this API should be shaped out. And this will also be mainly this presentation, how can we think about this kind of concept. And then we have also a project with DTU, the Technical University of Denmark, together, where we have connected kind of a Kubernetes cluster to the laboratory and unit operations they have in the pilot plant facilities to get the data, and also make use of machine learning models to maybe even interact with those actuators you have for controlling the unit operations. So this is kind of the one pitch slide of our company, how we envision our tool. It looks a bit different now, our software. But we want to kind of generate applications which can be switched on and off by our customers based on their needs, and we can have a flexible license price based on which kind of tools they want in this dashboard software. But the dashboard software runs on top of a REST API. So we can also sell the REST API, which the company then connects to their own dashboard. And here maybe just some companies or some tools which I find interesting, because Cameo, for example, is kind of a chemical property database where they've mined, or Loic has mined data from NIST webbook, for example, and makes it available through his interface, but you can also access here, again, the REST API. PubChem is a very large chemicals database. They also have a REST API which you can connect to. Daniel from DWSim has made his process simulator actually some weeks ago. He had some experiments to put it in the cloud, and he was successful with this. So you can actually run DWSim on a server at AWS or Azure. I think this needs to be a Windows server, of course, because DW. Well, I think he also made it now work on the Linux. So yeah, this is how we see things are switching. It becomes more server-based, and then there's two companies who I bet they also have a REST API and make kind of dashboard use case applications for here with equation of state calculations for the oil and gas industry in the case of Whitson, and TLK Energy is kind of also a modeling-based company from Aachen, where they also do thermodynamic calculations and kind of dashboard tools. And here you can see just envisioning that you have on the left side kind of your chemicals properties database. You have DWSim, which could maybe communicate with this kind of REST API from here to retrieve some data, do some calculations, and maybe you want to make also a tailored dashboard interface to the calculations of DWSim. So this is kind of also what we have the vision with our software, but of course we're building some parts here ourselves. What is the REST API? So REST stands for representational state transfer. It's not a standard as CAPE-OPEN. It's kind of more of an architectural style, but makes use of standards such as HTTP, file formats which are getting transferred between a client and a database, for example, and in between you have the REST API, and here you send JSON, XML, or YAML files even. And you can create new data, you can read new data, or you update the data in the database through the REST API with those kind of HTTP methods you have. You can also delete data in the database, but in between the database and the REST API, you can of course also have an application, and this application has kind of also an API which or is connected to the REST API to communicate with the client. If you work in pharma, you need to sometimes be careful not to say API. So I sometimes need to say application programming interface, because active pharmaceutical ingredients there, people get confused. And I won't go into cybersecurity here in this presentation, but there's a new book came out this year, and it's a really good book to just think about cybersecure things with the API. And why are APIs so important? The Gartner report says that more than 75% of global organizations will be running containerized applications in production in the cloud. So will be omnipresent, this kind of container-based application provision, where you can maybe on AWS Marketplace or Azure Marketplace regard it as an app store as such, like for your phone, and you buy the application you need, and then you run it on your own kind of server infrastructure at AWS or in a kind of virtual private cloud, or however your company has set this up. And today's researchers also estimate that all the kind of API calls make more than 80% of all the web traffic. So at MQS, also from a business model perspective, it's evident that we need to kind of shape out our platform in this kind of ways to obtain as many customers as possible. And we make use of Kubernetes because it's kind of a nice way of managing all those kind of applications which you have compiled as containers. And this kind of Kubernetes framework works in a way that is very easily scalable over different cloud providers or different servers you have, and based on the needs you can easily scale it up for if your user count just increases drastically to be able to provision still your software to them. And you can see here the containers sit in what we call pods. I will go to this into this a bit deeper later on with respect to machine learning too. And you will have to understand quite well Kubernetes to set something like this up, and we work heavily with DevOps engineers and have built this infrastructure which allows us now to run everything on such kind of a Kubernetes architecture. And then also something what people call is hybrid cloud, which will be very interesting if you think of process simulation software which runs on Windows servers, and you maybe want to run it under Azure, while you want to also have some applications running in AWS. And so this hybrid cloud concept where things communicate from one cloud provider to another cloud provider is also important to think about. And IBM did a study what is so important by hybrid cloud, and it's a good read. And you can see here cybersecurity is also very important with respect to this. So we at MQS also look very heavily into cybersecurity to be able to also ship a product in the future which is doesn't blow things up at a company. When the login, so we need to be able to port our tools based on the company's infrastructure, right? So we can deliver on AWS, on Azure, on Google Cloud, and also on premise. So we've designed our kind of software development workflow in a way that we have kind of compiled versions for different infrastructures, even for different kind of chip architectures, so that companies can make even use of ARM processors, which are more energy effective for some algorithms. And we have modularized everything so that we can even port, let's say, a single thermodynamic model as a container to a company. This is a project with DTU, so we've basically designed this whole concept through for them, and I was still working on this, but it's basically up and running. So we get data from unit operations through OPC UA. They bought a Siemens system back then, which is not that flexible as other systems, so we had to interface the Siemens system with something, a Spanish company called vNode, where it makes can connect to the Siemens system, but interfaces and allows to connect through different protocols to vNode. And here we make use of MQTT to get all the data from the unit operations through Siemens, through vNode into our database, which is running on Kubernetes. And then here you can imagine you have the database running in one pod, as explained before, and then you have your process simulator or whatever algorithms you've containerized as a digital twin, if you want to call it like this, and you can make then use of this digital twin to send data back to the actuators in this unit operation. So now quickly to CAPE-OPEN. So there's not much to explain to you. You've heard of Jesper already what components are and environments in CAPE-OPEN, but just a very kind of thought and how I'm thinking about this, but I could be wrong, so this is also, I'm very excited to get some feedback on this presentation later on, also by mail or however you want to contact me. So on the component side, we have unit operation models, we have numerical solvers, we have kind of thermodynamic models. If you want to be as modular as possible, you could maybe imagine to containerize each one of them, or kind in a logic where they all fit together, and you have basically created a library of containers with your databases or your data and your models. This can then run in a distributed fashion on a cloud infrastructure. So imagine your model would profit maybe from parallelization or being run on a GPU instead of a CPU. So this is kind of the infrastructure we are having now available, and this would be interesting also. How do we think about components being run on this kind of distributed cloud infrastructure, but also how do we interact or how do we control those components within a modeling environment. And also on the modeling environment side, it's very interesting if you think about different programming languages or different operating systems they're running on. Now with hybrid cloud, you can actually circumvent this kind of communication problem between tools, because you make use of, let's say, a Windows server and a Linux server, and you run, let's say, your Pyomo or jump optimization model on a Linux server, have containerized it as a application, but you have, let's say, DWSim or a Windows process simulator running on a Windows server, and you let those things communicate with each other. But this is something we are looking into, but of course this is kind of a design exercise which also takes quite some time, and you have to take a stepwise approach here. Here is a tool we also are deploying for DTU to make use of machine learning models, and that I like this picture very much because you can see here a flow diagram of all the different steps in your machine learning model, but you are actually dissecting the steps, putting them into containers, and then running them on different pods, and those different pods are running actually on different devices. Let's say the training the model takes most resources, and you want to then run it, for example, on a GPU device. And this is something we are imagining this will be more standard in some years, and that's why we are also looking into how can our platform also benefit from integrating, for example, also Kubeflow into our platform. On the quantum computing side, also there's a company from Canada which also has this kind of concept like Kubeflow, but they really specialize on distributed computing and even like running it on a quantum computer, some tasks. So this is also open source, this tool, and this is also something we are having a workshop on, even to make use of quantum computers for some parts in your algorithm. So our ideas now with COBIA is that, of course, we are mostly focused on thermodynamic and physical properties, which we have in our database, but also have some models based on also quantum chemistry calculations. And we want to look at COBIA so that we design a REST API inspired by COBIA or by CAPE-OPEN, but also in line with good REST API practices, to be able to maybe come up with a design which allows people to save time when they design a REST API, to just take the scheme, which we might have published in the future, and hopefully have published in the future when we come up with something useful for other parties as an open API definition, so that people can take this as a guideline how their input and output of their kind of applications should look like, so that people don't have to interface with their tailored scripts always a different kind of API structure. And then we would like to see if we can, in a hybrid cloud setup, make use of our tool in combination, let's say, with process simulators and other CAPE-OPEN compatible components or environments. I didn't go into much into parallelization and MPI and all those kind of tools or concepts to parallelize algorithms, but there's also some nice papers out there for this kind of stuff for high performance computing on Kubernetes and container orchestration. Yeah, and then just a remark, we have a quantum computing workshop coming up in November if you're interested, and we're planning to also together with our infrastructure or our platform to deliver also some other workshops which basically teach people even more about this kind of stuff I've just talked about. So feel free to reach out. And thanks for your attention.